Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this Bally Captain Fantastic sweet freaking pinball machine for a customer. He brought it by. He's already done some cosmetic stuff to it, but he wants us to get it working. So it's not working right. So I'll start it and show you what we got it doing in the last video that you may have missed. If you did, go back and watch it. Let's see if it'll cooperate. I can't even remember where we got to. Oh, look at that. Good to go. Alright, so the playfield lights are not working. Flippers are sticking. And it stays on the first ball and the first player. Well, first player. Every time you play it. I don't know what that buzzing is, but we'll figure that out. There's no back glass, obviously, which is the coolest part of a Captain Fantastic. But the reason there's no back glass is the customer didn't bring it because he didn't want to break it. Don't blame him a bit. So he left it at home. Although I will say, the safest place to keep a back glass is in the pinball machine. But then if you're moving it, it's easy to knock it, so I get it. Alright, so I'm going to turn it back off. Basically, we need to work through the things on the bottom of the playfield like we usually do. On the previous video, we troubleshot a little bit of the stuff, but on this one, we're going to go through and start cleaning all of the freaking relays like we always do. So let me get the playfield out of it, and then we'll see if anything looks crazy inside, or if it looks like, you know, we kind of need to look at the coin unit and the ball count unit and all that kind of stuff. So let's see what's underneath this playfield. Alright, so here's what we got. Everything looks pretty good to me. A little dirty, but aren't they all? This is the coin unit that tells it if you've got 1 player, 2 player, 3 players, or 4 players. This is the ball count unit that tells you if you're on ball 1, 2, 3, 4, or 5. So this definitely should have been advancing. So let's see if it will advance. I think this resets it. Seems reset. Yes, it will advance, but it was not advanced. And it will reset. So, whatever tells it to advance was not telling it to advance. Let's see if the coin, the coin unit, let's see if it will advance. Ooh, I see a couple weird faults. I'm going to have to pull those out and show them to you. But yeah, it will advance. It just isn't advancing. So there are, you know, a bunch of other switches that send the power over to those machines. If they would get the power, they do have the physical ability to advance, so that's not it. But there is a problem on the back of each one of them that I'll show you. Alright, so this is the coin unit. So the thing that I'm noticing that looks wrong is that coil on the bottom, which is the step-up coil. Look how they have bent that out of the way. I don't know why that's like that. I don't know, man. Maybe it's supposed to be like that. I don't remember ever seeing that. But this one's the same. Let me see if I can find a drawing of one of those or something. See if that's supposed to be bent like that. I don't think that, that assuredly would not keep it from stepping up, but it's just weird. Something I noticed that I've never noticed before. So here's the credit unit in the back, and you can see that same part is not bent on these. So I wonder why they did that. If you look at it from the top, that has to do with, since that pin runs through that plunger, that being bent or not bent has to do with how far the plunger is allowed to come back out of the coil. Interesting. Look at this. Check this out. That's the little piece right there. Base plate tab. That is your base plate tab, people. Surprised you didn't know that. Credit unit. Okay, so they're all the same, but this is this particular one. So the credit unit, of course, is the piece in the back box that we were just looking at. It's not bent, but the other two are. It says, to check for proper adjustment of the credit unit. Okay, well, you know, if we properly adjust the credit unit, and then we do the same thing for the coin unit and the ball and play unit, it's probably going to be properly adjusted. Slowly hand actuate the step-up plunger. So you push it in. Just the step-up plunger, the one right next to it. You push it in. Hand actuate it. The step-up arm must not engage the next tooth on the ratchet. Occasional engagement is acceptable. The step-up arm, okay, must not engage the next tooth on the... Oh, that's because it's going to be slightly different. If the step-up arm does, gently bend the base plate tab down away from the step-up solenoid until hand actuation does not cause consistent engagement of the next tooth on the ratchet. This adjustment, properly made, prevents multiple crediting when only one credit is due the player. So if you bend it down, it only lets it give you one credit. Huh. All right. I don't know how much that helps us, but I guess that's what it's for. So apparently, moral of the story, yeah, you are supposed to bend that according to the manual. You know, let me go ahead and put something else to rest while we're looking at this manual. Okay, let me show you something here, folks. Assembly adjustments. This is in the Captain Fantastic manual from Bally. Who better than Bally to tell you how to do it? All switch assemblies consist of leaf springs, contacts, separators, plastic tubing, and screws to hold them to the mounting surfaces on the relay frame. Before attempting to adjust a switch assembly, make sure that these screws are tight. If not, tighten screw closest to the contact end of the leaf spring first. This will prevent the assembly from being secured in such a manner that the leaf springs tend to fan out. In general, all leaf springs are adjusted for a 1/32 of an inch gap in the open position and a 0.01 inch overthrow or wipe in the closed position. So they're saying that they should not be touching when they're open and that they should push past each other a little bit when they close, okay? And I apologize to our European friends who don't use inches. You'll just have to figure it out. It's kind of a... It's supposed to touch just a gnat's hair, right? However millimeters that is, however many millimeters that is. But here's the thing: all contacts should be in good condition. Unless otherwise instructed, they should be dry or non-lubricated. All contacts should be free of dust and dirt. Tarnish can be removed with a contact file followed by a burnishing tool. Severely pitted contacts must be replaced as an assembly. In general, contacts need to be cleaned or replaced and adjusted when they are found to be a source of game malfunction. So is our game working? No. What does the manual tell you to do when the contacts are tarnished? Use a file on it, right? I didn't invent all this, people. I mean, this is old school stuff. People were doing this long before me. You use a freaking file on them. I've had so many people tell me to just use a business card. That works if they're just dirty. They're not just dirty. They're all screwed up. They got lots of problems. You got to hit them with something a little more aggressive. I don't use a really aggressive file, but I use a little flat file. All right, so anyway, that's that. So yeah, that's what you're supposed to do. So that's what I'm doing. I'm going through and cleaning switches and stuff. But that little tab being bent, apparently that's not that big of a deal. Apparently that's how it's supposed to be. So if the thing works properly, we're just going to leave them bent. All right, so this is the ball count unit. The first thing we need to do is make sure that the two switches down there on the bottom are working properly when the ball count unit resets. So those are two switches. See the little blade sticking out there to the left? And see that little plastic post there that's going to hit it? So those switches are closed right now. See if I can get you down in there. Look, folks, I'm not Steven Spielberg, all right? Okay, look at that. All right, so whenever I hit this, it's going to reset the ball count unit all the way to the beginning. See how it opened the switches? So they're open at the home position. And then when it pushes in one position, they closed. And did you see how far they moved once they touched? Is that 1/100th of an inch? I don't know. I don't know, folks. Okay, so it said it should move past about 1/100th of an inch. Right? And it said that it should be open about a 32nd of an inch. So it should be open 3 times more, 3 times as wide as it pushes past the switch. Okay? So get a gander at how far apart those are. Okay, now whenever I close them, do they push through a 1/3 of that distance? So now they've closed, or pretty much closed. I don't know, I think it pushes a little more, but I don't know. So I think we're good though. All right, so those are working properly though. And I haven't even done anything to the units. They're actually working fine. This one over here has a similar switch. I guess I should show you this one because it works a little differently. I've showed this on like 10 videos. This is one of the coolest parts of these on these Ballys, in my opinion. So here we have a really similar situation. Do you see the little plastic piece down there that is being used to open the switches over here? Where is it? Down there. So see, it's hitting a switch and opening it over here. Okay, well over here there's no switch there for it to hit. The switch is up here. And they have put another post on there at the factory because this one is going to work differently. So this is just a strange, I don't know if this is like the only instance of a switch that works like this or not. There may be in other parts of the thing there's something like this, but when this resets, oh, that's the step up. When this resets, let's watch this switch. So that's reset. That's position, we'll call it position 1. The first position. If I can... That's position 2. Did not hit the switch. That's position 3. It's touching the switch. Yeah, it's opened the switch, so we're not adjusted right. Closed it there, and that's position 4. 4 is open, but as you saw when I was messing with it, it was open at 3. Okay, so let's watch one more time. Position 1, position 2. Now watch. If it's not open, it's real close to open. See, it's not really touching. So that's adjusted a little tight. Now, what does that switch do? That's the coin unit. So basically, when you start a 1-player game, it stays at the home position. When you start a 2-player game, that moves up to the 2nd position. When you start a 3-player game, that moves up to the 3rd position. And then you hit start one more time, and it moves up to the 4th position and opens that switch. When you hit start for the 5th time, which would waste a quarter, it doesn't allow you to because that switch is open. So that switch saves you from losing money. It's a very unique thing. The operators or the designers of the game designed something in that only allows you to press the start button 4 times so that you don't lose a credit. So out of all of the times, all of those years, all the horrible things that you people have said about how it's a ball drainer, it's a trap, it goes over on the left too much, oh, the gap between the flippers is too wide, there's magnets in the end lanes, they angled the drop target so the ball will go straight down the middle. What they really did was they designed something in so you wouldn't lose your credit. Look at that. You should be ashamed of yourself. You should be ashamed. For shame. For shame. I just think that's a unique little design feature. But right now it's set up where if that opens at the 3rd coin, all that means is you would only be able to start a 3-player game. So we're going to bend it slightly. Too much? I don't know. You tell me. So now we're still on 3rd. Oop. See how it's moving it just slightly? So that's pretty good. Maybe we'll look, I done cut myself. Maybe we'll try to bend it just a little bit more. There's a little tool you're supposed to use for this, but I don't have it with me right now. Blood, folks. Blood runs right on the highway. There we go. See how when I move it, the small blade is moving just slightly? That's because it's closed. Whenever it's closed, it's actually touching it. So, if we reset it, position 1, position 2, position 3, it did move it, but it didn't open it. And watch, it's going to go backwards just a little bit. And then position 4. Bam. So I think that's properly adjusted. Okay, I'm going to go clean all the blood. Look at that. Ugh. That when I was a kid, I saw this, I probably shouldn't have been watching it. I was watching, I think it was one of the police academies or something. Shouldn't have been watching that, you know. Was it Police Academy? Might have not been Police Academy, but anyway, it was the whole, I might have that, was it Police Academy? I can't, it was some movie like that. It was like a cop movie. And so basically it was people that, it was the one with Where's the Beef in it. Whatever movie that was, with the woman, the Where's the Beef woman in it. I think. I might have this all screwed up. But anyway, in the freaking movie, they all have to go to driver's ed, basically, because they've all got tickets for driving screwed up. So they all get tickets, and they get sent to this driver's ed class. And when they get to this driver's ed class, these are adults, whenever they get to this driver's ed class, they play them this movie that's supposed to scare them into driving better. And it's called Blood Flows Red, dun dun dun, on the highway. So every time I cut myself or something, I always think of that movie, Blood Flows Red on the Highway. The whole thing was a comedy, you know, it's supposed to be funny that they're shocking everybody by showing them this stuff. When I was in driver's ed, I think, though, they did show me some kind of movie like that, but it wasn't called Blood Flows Red on the Highway. So anyway, that's that. So I'm going to clean the other side here. So you saw how they're all advancing and resetting just fine. So what that means is basically you just need to get the rivets clean over here. Now, you may notice that they use different spiders. So on this one, the ball count unit, they use a more simple one. That's kind of a more traditional one. But this one, they use this cool multi-fingered approach. Look at this. And so as it advances, it just... So whenever it's at the one player, right? So it's only a one-player game. One of these contacts is touching this line. And then all of the other contacts are touching this next line. So it's connecting 2 wires, but I guess there's not even a wire there. Okay, and then once it steps up, now it's connecting this line to this line and that line. Then it steps up one more. Now it's connecting this line to that line to that line and that line. So there's 4 of them connected. And then when it goes one more, Now this line is connected to this line and that line and that line and that line. Just a very interesting way of doing it. I think maybe we'll look in the schematics and see what exactly they're doing with that. That may just be where they're turning on the light bulbs.
Traffic fatalities are increasing everywhere. And that's why blood flows red on the highway. Here we see another accident. Two trucks collide with a Toyota.
Alright, so the coin unit is used in three places. One is it's used in the match area. Basically, at the end of the game scans through, and as the score motor is turning, it awards credits if you match, depending on the position of the coin unit. Because basically, if player 3 gets a 10 and the match number is a 10, but you're only on a one-player game, that shouldn't even be possible. I guess the only time that would come into play is if it was 0. Let's say the match number is 0 and you're in a one-player game, all 4 scores are going to be 0. So you would win 4 credits. So to keep that from happening, they use the coin unit. Okay, so that's one place. Another place is on the lights that tell you the number of players. Okay, and then another place is they need it to tell the game whether to step up the ball count. So typically whenever you play, if you're playing a one-player game, when the out-hole relay pulls in, if the ball index relay has been tripped, which means if you scored any points that ball, and if the extra ball relay is not on, as the score motor turns, click, 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 click. On a one-player game, it will tell the ball count step-up solenoid to step up. So then you'll go to ball 2. But if you're on a 2-player game, it can't do that at the end of ball 1 for player 1, because then player 2 would start on ball 2. So the way they do that in that instance is the player up disc has switched over to him. Okay. So now when the same thing happens, on 1 it doesn't do anything. Wait a minute. Wait a minute. Oh yeah, if this disc has moved over to here, that would no longer be connected to anything. This is the player up disc. So on 1, it would be here, it would only work on the first player. If you're up to ball 2, if you're up to player 2, it would just move this from here to here so that it doesn't advance the ball count until player 2, or player 3, or player 4. Alright. Now, you'll notice that that one can't be the specific finger that we were just looking at, because the finger that we were just looking at is shorting all of the lines together. So that wouldn't work. You wouldn't short the one finger to all 4 of these, because then it would make it where it steps up the ball at the end of the first player, the end of the second player, the end of the third player, and the end of the fourth player. So that one must have individual wires going to it. This one over here, however, would. I believe this is the one that we were just looking at. So the first player, one player can play, is lit up just by lights, just by the transformer. And then the second one comes on if you move the coin unit up to 2. That's when it's short. Remember how I was saying that the one wire, the one track doesn't look like it's shorted to the other. It's shorted the other track, but there's not 2 wires. That's because this is shorted to there. And then when you moved it up, it shorted to that. And then when you move it up again, it shorts all of those together. And when you move it up again, it shorts all of them together. So it's basically turning on the lights and leaving them on, because 4 players can play. So that's one of them. There's another one on the other side that does the exact same thing. It's the other one that we were just looking at. Where was that? You were just looking at it, folks. Oh, the match unit. So it has to do that too. So if there is a 4-player game, basically all of that. You remember, the coin unit just moves at the beginning of the game when you hit the start button. It resets after the game, but it doesn't move during the game. So whenever that's shorted all the way up to number 4, it's doing that so that when it scans through for the match, as the score motor scans through at the 4th position, the 5th position, the 6th position, the 7th position, it goes bam, 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 and gives you your 4 credits if you're supposed to win 4 times. It's just how the match circuit wins. So anyway, that's the purpose of the coin unit. Since we couldn't start a... Did we try? I think we tried to start a 4-player game. But since he was saying that it was stuck on a 4-player game. So anyway, this is what the thing does. It only does those 3 things, and it looks like they're working just fine to me. But whatever tells the coin unit to step up would be a problem. It very well could be the coin relay. So whenever I hit the start button, the coin relay will pull in. And as the score motor is turning, if the reset relay has turned off, the coin unit should step up. So the first time you hit this, it's going to turn on the reset relay. So this is going to go over here. That will make the coin unit reset back to the first position, which is a 1-player game. It won't step up until the reset relay is done. So after the game resets and everything, it kicks the ball out. Bam, you're sitting there. Then you hit start again. Well, the reset relay is over here now. So the reset relay is kept from pulling in when the second time you hit the button. Boop, boop, boop. Let's see here. Because it connects through the game over relay. So the next time I hit it, it's going to pull in the coin relay again. But since the game over relay is not tripped, it can't get power over here to the reset relay. Just, you know, the whole thing's pretty cool. It's pretty slick. Very high level design here. And we were showing it on the first video. Look at these schematics. If you don't have a paper copy of the schematics for your pinball machine, people, what are you thinking? What are you thinking? There's nothing more cool. Look at this. It's the ultimate thing you need to have for your pinball machine. You can fix everything with it. There's so much information in here. It tells you so much. It's like a big puzzle. Look at this thing. It's incredible. Oh, let me show you something else that's real cool. So this is the center tap. This is the ground, basically. Right now it's AC, so it's not really ground, but you get my point. It's the neutral. See, it's in the middle, and then down here you have the lights, and it stops here, okay? So the lights also connect to the neutral, right? And then up here you have the high voltage. But look how they've designed this. The neutral goes all the way around, and then they loop it around because they got more stuff that connects to the neutral. Look at all that. So the schematic is really twice that long. If they laid it all out with the voltage, the voltage here and the neutral here, they would have had to draw all this past the end of this line, just kept going. They're kind of complex. That clip was from Moving Violations, if I didn't mention it. I couldn't remember the name of the movie. I was like 6 when I saw it. So. Okay, so we have this unfortunate situation where, see how that's like over travel? So watch this. So it pulls up to the next position, and then before it goes in again, it travels backwards. The reason it's doing that is because they bent that tab. It could be that the thing bent the tab itself by just slamming into it. I don't believe so, though. So because that tab is bent, God, if I can get some, get it where you can see it. Because that tab's bent, it allows that arm to travel just a little bit, so there's a little bit of play. And that is the backwards motion you're seeing. So if I were to bend that tab back, that might hold that in and limit that a little bit. Okay, so that's what we're going to do. So I'm going to take those loose, bend it back with some pliers, and see if that helps that a little bit. If you've got a little bit of that, it's fine, but that's kind of excessive. All right, so I took the screws out of the bottom, and I bent the piece back with a pair of pliers, best I could. And now that doesn't allow that arm to travel so much. So if we check it again, so that's home position, first position. Now watch, it still will back travel just a little bit. But that's pretty typical. You got a little bit of that going on. If I were to bend that thing the other way, it may actually fix that. There's probably just a little bit of wear here and there that's allowing that to happen. So on this one, I did the same thing. Now, when you get to the home position, on a lot of these, the home position, sometimes they are sitting weird. So for instance, look at these two contacts here. See how the top contact is almost off of the rivet? It is still making contact. But it's almost all the way off that rivet. You can adjust that by moving this Bakelite board. There's a couple screws, one there and one across from it, that you can loosen, and you can turn that thing. Sometimes you can even just turn it. It'll be just loose enough that you can turn it by hand. But the problem is the home position is often different from the rest of the positions. So I'll show you what I mean. Now if you look at this one, that looks about right, correct? And then on this side, it also looks about right. Everything looks lined up. Okay, so first let me show you the travel thing. So we'll get that out of the way. Let's look at the top one. Okay, so now it just barely goes back. Right. The problem is there's big old meaty traces up here, but down here it's a little more, you got to be right on it, right? So it's proper there, it's proper there, it's proper there, and it's proper there. Okay, so I'm a little more worried about that being perfect, right? And over there, they all line up just the same. We're looking at it from the other angle, so it looks like they're off, but they're not. So these being just kind of hanging on the edge there a little bit, I'm not quite as worried about. Because if I get that where it lines up right in the middle of the trace, which would be all pretty, both of these would be off. So we're going to leave it. All right, but as you can see, it does travel back just a little bit, which is typical. And there's a different adjustment on those depending on the company that made them. The Williams adjustment is different, and the Gottlieb adjustment is different. So anyway, to me that looked strange that they were all bent. I think it's just because most of the ones I work on, they've never adjusted that. And by bending it back perfectly straight, that pretty much got it where it's adjusted the way I feel it should be adjusted. So I don't know why they bent those all out, but whatever. So that's that. Okay, so I've already went through and cleaned the switches and also cleaned these switches. I didn't find much that was out of adjustment, but a lot of them were dirty. So hopefully whatever was not allowing the coin unit to step up and not allowing the ball count unit to step up has now been repaired. So we'll see if by the end of this video we can at least get it to advance from ball 1 to ball 2 to ball 3, etc., etc., etc. So I think since we've done all of this, I also cleaned the Jones plugs. I see something here I need to fix. We're going to take care of this before I was about to say I'm going to put the playfield in, but we're going to fix this first. So this is a fuse holder, but if you look, they have soldered the fuse in. So, I know a lot of people, and we do the come on people joke. I know a lot of people like to bag on people for doing crappy repairs, but we don't know the story behind this. Some of these games made it overseas, and it's in Zimbabwe, and they don't have any parts, and they make it work. I don't know. Maybe it was in Montgomery, Alabama, and they didn't have the parts. I don't know, people. I don't know. I don't like to be critical of previous repairs because they tried to make the thing work, you know. Maybe we could figure out what that fuse even goes to. Is it a fuse for this motor here? I don't know. Doesn't look like it is. I don't know what that fuse even is. It may be... We're unplugged, by the way. A blue and orange wire. You know, none of the playfield lamps are working. I wonder if it has anything to do with that. Now, there are other fuses over here. And you can see on the paper legend there, 6 volt, that would be lamps. 6 volt, that would be the other lamps. And 50 volt. So these are the solenoids for the whole game. These are the lamps for maybe the back box. These are the lamps for maybe the playfield. But I don't know what that one's for. So I think we probably need to replace that fuse holder. It probably said right there or right there. Oh no, look, it says it right there. It says it. What is it telling us? Would I put it in the wrong place? Let's see if maybe that's just stuck under there. That's a sticker. F1338 something amp. Alright, we're going to find that in the schematics. You see what I'm saying about the schematics, people? So here is our 15 amp fuse for the playfield lights. Here is our 15 amp fuse for the back box lights. Yeah. Here is our 10 amp fuse for all of the coils. And that one that we were just looking at is an 8 amp fuse, blue wire going to an orange wire. That is just the main fuse. And the reason it's down there is because it's in line with the on-off switch, which is behind the front right leg. So that actually makes a lot of sense. So I'm going to swap that out with a nice new fuse holder so there's no more problems. And we'll get rid of that solder so that if you ever want to change the fuse, you can. Alright, so I've pulled out the other fuses on the side as well. And one of them was a 15 amp that is running the back box lights. This one is a 10 amp that's running the solenoid, so that is correct. But, another thing, it's actually not correct. Check the finesse here, people. I don't know how well you can read it. I'm trying to help you. Come on now. Basically you got to get it close to what it's focusing on. The light is working against us. Come on now. 10, you can barely see it, 10 amp, 10A, 32 volt. So you see the problem. It's a 32 volt when that's a 50 volt line. So that fuse can't work in that. And then on this one, let's see. This is the one that's blown, which is the playfield lights, which are not working. But it's a 10 amp fuse. And it's supposed to be a 15 amp. Ironically, this one is a 250 volt, which means it would have worked for the other one. But it's blown now. Alright, so we're going to put the correct 10 amp fuse in, and we're going to put the correct 15 amp fuse in, and then we're going to put the correct 8 amp fuse in, that other one, and we're going to see if that gets any of it to work right. Alright, brand new fuse holder. Wire soldered on. Look at that. Beautiful. Now we're going to have some good juice running through this thing. Alright, so it's time to swap the playfield back in and see what we got. Alright, so the playfield is back in and plugged back in. Now, we may be running into another problem. When you have lamp problems where it's blowing the fuse, that is often a very hard problem to figure out. Here's the reason. Let me draw it on a piece of paper. It'll be easier to show you. All right, so here on the schematics, it says general illumination insert. Can you even see me? Yeah, general illumination insert. And over here it says general illumination panel. So that is the playfield general illumination, and this is the insert. But look how they have this drawn. There's just a line over here connecting to the 6-volt to the one fuse, and then a line up here connecting to the neutral. The other one is showing a line connecting to the other 6-volt, which is the other fuse, and connecting to the other. Well, it's connecting to the neutral. It's the same neutral. So I'm going to draw how they did it and explain why it's really hard to figure out why it's blowing the fuse. Okay, so you get to see my great art skills. So you have the transformer over here. It's like this. Right? Down here it's 6 volts. Up here it's neutral. You with me so far? Okay. And then they connect a light bulb to it. So these lines run onto the playfield. They connect a light bulb. The resistance of that light bulb, I will tell you here in just a second. So the resistance of the light bulb in ohms across the filament of the light bulb is 4.1 ohms. I just measured one. Alright, now this looks like it's going to be real complicated math. It's not. You'll all be able to understand. So that's 4 ohms, we'll say. So if there was only one light bulb, you would check the resistance between this line and the resistance between this line with your ohm meter. And it would say, hey, there's 4 ohms resistance. Everything's cool. And you'd say, yeah, it's 4 ohms resistance because that's the resistance through the filament of the light bulb. Now the transformer has its own resistance. It can be all kinds of things. I don't have any clue how much that is. All right? But then here's how they do the next light bulb. They connect it the same way. It's in parallel. So series would be if another one was connected here and another one was connected here. No, it's connected right beside the other one in parallel, and it uses the same 2 lines. The neutral line and the 6-volt line coming off of the transformer. Now on this particular one there's 2 fuses, so that divides it in half. So it's blowing, the playfield fuse is the one blowing. Right? So what is the resistance of this bulb? Well, it is also 4 ohms. So what is the resistance for electricity to get from here to here or here to here? It's usually, you know, the least path of resistance, or the path of least resistance. So normally it would be 4 ohms, but that's not really how it works. Let's say you have a dam. This is how I finally figured this out. Here's a good way to think about it. Let's say you have Hoover Dam here, right? And there's a big old lake back here behind it. Here's some mountains. Oh, I'm doing my Bob Ross thing again, aren't I? I need to show you I got a present in. This video is going to be too long if I talk about the present. Somebody sent me a present. All right, so this is Hoover Dam. Doesn't it look just like it? Hoover Dam at the bottom has a big hole in it with a door on it. Okay? And there is water all back behind the dam. Water runs from the lake into the river down below Hoover Dam. And they control it with that door. Okay? So let's say that there is, let's think of this like resistance. That's kind of how a light bulb works. Power runs through it, but only a little bit. Right? It has some resistance. So I don't know if you want to call this isn't a direct analogy. Some of you techies are going nuts that I'm even attempting this, but you'll be all right. You'll be all right, people. This makes, I'm just saying this for one reason, because it helps explain what the problem we have here. So you got a hole in the dam. So much water is allowed through it, right? This light bulb only has a resistance, so it only allows so much current through it, all that crap. Okay. Now, if you were to take this dam and add a second hole, did that increase the resistance? No, it allows even more water to come through now because you got two, right? So when you add more water can come through, right? That's kind of how this works. If you've got one light bulb, the resistance is 4 ohms from here to here if you were to measure it. But once you add a second one, it actually drops the resistance. Now the resistance is only like, I don't know if it's 2 ohms, it might be 3 ohms, whatever. I'm sure there's a formula. But there's a formula. It lowers the resistance. Okay, well now you add a third one. And then you add a fourth one. And then you add a fifth one. And then you add a sixth one. And each one of those bulbs measures 4 ohms resistance, but added together, it lowers the resistance of these two lines. So whenever you check it, it doesn't say 4 ohms resistance. It says some crazy crap like 0.2 ohms resistance. So you think, oh man, there's a dead short on the playfield. But you can't tell where it is because you can't measure the resistance right. Because all those freaking light bulbs. So a light bulb, the way it works is it's a dead short, basically. The filament is literally glowing. The wire in the light bulb is glowing because you're running a bunch of juice through it, right? So once you add in all of the lights on the playfield, I'm just going to look real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 20... There's at least 20 light bulbs on the playfield, at least, and they're all connected like this. So if there is a dead short on one of these sockets, you don't have any way of telling. If you measure the resistance, it's pretty much going to read a dead short anyway. If you take all of the light bulbs out, then you would get the resistance of whatever it is across the transformer, which may be very low too. So if there's a short, it will blow the fuse as soon as you turn it on. But then you play hell finding the short. It could be here, 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 here. Any of the light bulb sockets, any of the wiring. And you just have to look for something obvious. So if there is a, like the playfield keeps blowing the fuse for the lights, it's a pain in the butt to find it. You just basically have to look at every single wire that runs to these bulbs, or look at every single socket until you find it. Now, sometimes you get lucky, and you can tell that, like, it does the left side of the playfield first, and then it jumps over the right side of the playfield. So you can go in and cut that wire, and then turn it back on and see if all of these light, but these don't, or something like that. But it's just a pain in the butt. So hopefully, we don't run into that problem. But if you think about the resistance lowering, it makes more sense to me, at least. If you think about a dam, if you put another hole in a dam, more water goes through it. It actually lowers the resistance to the water flowing through it. There's less resistance. You're getting more water through it, right? This doesn't work exactly like that, but it's how I keep it straight in my head. So all I'm saying is it's going to measure like a dead short if you try to check it with an ohm meter. Ohm meter is almost useless in that kind of situation. So when we turn it on, it may work fine because it had a 10 amp fuse in there, and it may have just blown because it was a 10 amp fuse and it should have been a 15 amp fuse. Or there may be a short blowing it. If there is a short blowing it, the only chance of a clue that you have is to watch the lights as they come on. So they might light up, and this one lights up crazy freaking bright. Or it might come up and these three work, and then these don't, you know. So sometimes you can get a clue just by how quick it burns out and like what's going on with it. So we'll go see. Hopefully none of this will even be necessary and everything's fine and it was just the wrong fuse. All right, so I'm gonna turn it on. It may immediately blow the fuse. We're looking for play-field lights. Okay, so it didn't even try. Let me look at the schematics to make sure that there's not a tilt relay or something that turns those off. It ain't looking good, folks. Yeah, they should be on. So it could be a bad connection or something. Another thing that it could be is that there was a short or something and it blew out every freaking light bulb. So I don't know. All right, so we'll mess with that here in a minute, but let's check and see if it will go past ball 1. It reset to 0. It didn't kick the ball out because I've got it inside. Rip. What them flippers are. Very buzzy, folks. I forgot I had the scissor flippers. Okay. All right. Ball 2. Let's do that one more time with feeling. Okay. The drop targets are not working. He told me about that, though. Ooh, man, they don't even fall. They just brick. Worst drop targets ever. Ball 3. We've got it set on 5 ball. All right, so it's flipping, all that. Ball 4, that's cool. Now we're waiting for it to go to game over. So game over are the lights past ball 5. Oh, we were on ball 4. If I could count, that would help my skills here. All right, it seems like most of the stuff is actually working. Game over, and it did not kick the ball out. So let's see if we can start a 4-player game. Those are signified by these lights. So see the 1, that's light 1, 2, 3, 4. The customer did not bring us his back glass because he didn't want to break a $450 back glass. I don't really blame him. Okay, so that's a 1-player game. Now, if that coin unit is working right, when I hit start again, it should go clunk and move that up to 2. And it did. Notice both lights are on. 1 can play, 2 can play. 3. 1 can play, 2 can play, 3 can play. Now here was where the switch was, I felt, open. So I should be able to hit it again, though, and it go to 4. Yeah. If that switch was open, it wouldn't have let me start a 4-player game. Now when I hit it again, it shouldn't do anything. It's not doing nothing. Because the switch opened and the operator saved your quarter. Alright, so let's see if it moves from 1-player to 2-player. Which, remember, is... well, I don't know if the coin unit... Yeah, I guess the coin unit does that. It doesn't allow the ball count to go up. Yeah, there we go. Look, it still says player 1. And it stayed on ball 1. So that's the problem that the guy was noticing. So we started a 4-player game, and it's not advancing. There we go. Now we see some broke stuff. So it can advance from player 1 to player 2. It eventually kicked the ball back out, but we're still on player 1. But you know what? Let's see if we can figure out the light bulb thing. I figured out the light bulb thing. I was going to do this as a... I was preloading my joke here. So when I put the fuse in, I didn't really put a fuse in. I put a breaker in so that if it blew it, I was going to go, come on, people. You didn't think people, come on. Why would I put a fuse if I knew it was going to blow? People, come on now. I'm going to use a breaker, then it don't blow. But the problem is, the breaker isn't making very good contact. Right? Look at it in all of its glory. Look at it in all of its beauty. All right, so I'm going to turn it off, swap in a real fuse, make sure it's making good contact, and then since that's easy, we'll see if we can figure why the ball count unit isn't advancing if it's a more than 1-player game. All right, so just a minute ago we showed the ball count step-up unit solenoid. We showed how this worked with the coin unit. So it should go from ball 1 on a 1-player game. It should go through the coin unit to ball 2 by connecting this and making the ball count step-up solenoid fire. And it did, remember? We went from 1 to 2, no problem. We went from 2 to 3, no problem, 3 to 4, no problem, 4 to 5, no problem, and then 5, it stepped up the ball count step-up solenoid to the 6th and final position, which put it in game over. So what does that tell us? It tells us that this works fine. It also tells us that this works fine, the coin unit. It also tells us that this score motor switch here works fine. The extra ball relay, normally closed switch, must be fine. The ball index relay must work fine. That's what pulls in if you score any points. So if the ball goes into the out hole, this out hole relay, there's another switch that kicks the ball back out and all of that, and scores the bonus and all that stuff. But once the out hole relay pulls in, it will not step up the ball count, like ours is not stepping up the ball count, if the ball index relay has not pulled in. Basically, you haven't scored anything, so it doesn't take the ball from you. You're still on ball 1. So ours is staying on ball 1, but only if we are at player 2, player 3, or player 4. Now, it could be that this coin unit disc, let's see here, what could it be? It could be that, well, no, it can't have anything to do with this, really. So this has moved over here to number 4 because we're starting a 4-player game. Well, that breaks this connection here, which allows the ball count step-up unit solenoid to step up. It can't this way. However, it's supposed to this way. All right? So whenever this gets to 2, 3, or 4. But that's not what's going on. We're not actually moving from player 1 to player 2. We're staying on player 1 the whole time. All right? So if you look, that's very simple too. It's right here. There is a player up unit step up solenoid that should fire. Now remember, all this is working fine up till here, and then it goes off this way. So that means to here it should be working. And then it goes through this switch on the schematic. I mean on the score motor. And this player reset relay, if it's this way, it would tell the player up unit reset solenoid to fire. If it's this way, it would tell the player up unit step up solenoid to fire. So this is going to go this way or this way. So it's at ball 1, player 1. If you're on a 1-player game, it's going to keep just telling it to reset back to player 1. Because this is going to pull in. The player reset relay will pull in and it will tell it to reset back to player 1. If you're playing a 2-player game, after the first player's ball, it will fire this. You know, it's doing this thing. It will also send power up here. It will tell it to step up, and it will step up to player 2. At the end of player 2, this player reset relay will go back this way and reset the player up unit, reset solenoid to send it back to player 1. So the player up unit is 1 position, 2 position, 3 position, 4 position, but it's in the back box. We haven't messed with any of that yet. So that's our problem. We need to mess with the player unit. It's involved with all kinds of crap. So we'll have to get to that next time. So the last thing I want to show you is how it looks with the fuse finally doing its thing. So let's go check it out. I'm going to save my artwork there. I'm going to have to frame it on the wall. Look, I can put it right up there. Got a spot for it. So we're trying to change the videos a little bit where we walk through specific problems that we run into on the machines. Hopefully that makes them more interesting. We used to do a lot of videos where it's just, okay, I'm cleaning all the switches. Okay, next, this is the switches you should clean. But I think what we're going to try to do is aim it towards specific stuff. Like, hey, look what I found wrong with the coin unit. Hey, look, the light bulbs don't work. Here's the deal with the light bulbs. So we're trying to lean more that way. It looks fantastic. Now, Joey believes that this gentleman has clear-coated the playfield. And I believe he's probably right. You tell me. I think those are paintbrush strokes. That's what I think. I might be wrong. But that's a very nice shine on that thing. I think he may have painted a clear on it. By hand. Maybe. Possibly. That could just be the grain of the wood that we're seeing underneath the paint. But I think it might just be a pretty nice hand-painted clear coat job. You know what would tell us maybe is the bare wood. So there's a little bare wood like right there. Oh, maybe not. Look at that. It does not shine. The bare wood does not shine. So that's probably just the original sheen that's been nicely waxed. Looks pretty good. Not bad. We're not going to do much cosmetics on this one. We just need to get it to work. And we've got it playing, but it won't play a 4-player game. Let's see if when we start it, it resets the 4-player coin unit back to 1 player. It does. So it reset it back to just 1-player game. All right. So very cool. All right, so we'll figure out that player unit next time. I hope you enjoyed it so far. Make sure to give us a thumbs up for taking the trouble to film it for you. Look, we stayed late. I didn't have to do that, folks. I didn't have to do that. I hope you enjoyed it. Make sure to leave your comments and let us know what you think, and make sure to check out my brother Donnie. If you don't know about my brother Donnie, he has a channel here on YouTube where he works on arcade games, pinball machines, jukeboxes. No, wait a minute. I got that confused. That's my channel here on YouTube. Donnie's channel is he works on old vehicles, mobile homes. He actually, to be fair, he was working on an arcade game today. He's getting into the business a little bit. But he works on old buildings. We've got some mobile homes that we've been restoring. Yeah, I said it. We're restoring the mobile homes. And he's got a farm and all that cool stuff. So go check out his channel, the My Brother Donnie channel. I'm over there with him a lot on the weekends. And we'll be back in a couple days with the next video in this. We need to do the drop targets. We need to do the player unit in the back box along with the other things in the back box. And then we need to like test all the scoring, things like that. There's a few light bulbs out. You know, we'll probably get those going, stuff like that. We need to look at those flippers that are buzzing like crap. I mentioned in the past in a video I shot just a few days ago on another machine. If they buzz a little bit, that does not bother me. Okay? So let me show you the difference though. So here's the right one. That's loud as hell. That's too much. That's way too much. Let's try the left one. Yeah, you got problems. If it goes, that's fine. Not, yeah, the world's ending. It's a little loud. All right, so we got to mess with that and figure if we can get that a little bit better. So we'll see you on the next one. I hope you enjoyed it. Have a good evening. This is Bally's fabulous Captain Fantastic.